Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 3208, alternating groups 2. This is a Google interview question based on sliding window. Let's have a look on the problem statement. There is a circle of red and blue tiles and you are given an array of integer colors and integer k. Color of tile I is represented by colors of I. Okay. They are saying that we are given a circle of tiles and tiles color are represented by this colors array. Colors array, in the constraint itself, the value will go from 0 to 1. So there is a colors array where the value is either 0 or 1. 0 means it is a red tile, 1 means it is a blue tile, and these tiles are arranged in a circular order like this. This is given to us. And they are saying that an alternating group is k contiguous tiles in circle with alternating colors. Alternating group. Alternating group is something, a group of k contiguous tiles. In this case it is 3. So if I just pick 3 tiles, this one and this one. These 3 tiles are contiguous and these are from this circle and these are having alternating colors. Red, blue, red. So these are alternating groups. Alternating group. Okay, now what we have to return? Return the number of alternating groups. There can be n number of alternating groups. Let's say these 3 tiles are making alternating groups, and the next 3 tiles, if I just ignore it, this one and this one, these 3 are also forming alternating groups. So just return the total number of alternating groups. Note that since colors represent the circle, the first and the last tile are considered to be next to each other. So this is the first tile, this is the last tile. So we also need to take care of that constraint that these tiles are arranged in a circle. Now I hope the problem statement is clear to you, and what is something we have to form is these groups, these colors are arranged in a circular fashion, 0, 1, 0, 1, 0, like this. And 0 means red color, 1 means blue color. And we have to find the alternating groups of k size. So let's say if I just form this group, this is a k size group and every color is alternating. If I just take a look on this group is also having alternating colors and it is of size k. So this is going to contribute to my answer. If I just have a look on this group is having these two, same color in these two adjacent elements. So these are not alternating color. So this group is not an alternating group and won't be contributing to my answer. Now let's try to understand what will be the answer of this example. 0, 1, 0, 1, 0. Here if I try to start with the index 0, 0, 1, 0. This one, this one, this one. This is one alternating group. So alternating group is now 1 in number. So these 3 are forming this group. If I just start from this index, these 3 are also forming alternating groups. Why 3? Because k is equal to 3. We will only check 3 size group. So alternating group will be increased to 2. And now if I start from index 2, so these 3 values, these are also alternating. So alternating group will be incremented to 3. But see, we are in a circular fashion. So we can either also start from index 3. So index 3 means this one, and the next one is the first one. So these 3 are also a group. And this group is not alternating because 4th and 0th is having same color. So the maximum answer is 3. Now if you try to analyze the pattern, here we are having a window of size 3. If we are not thinking in terms of window, and let's say there is no circular stuff, then how we are going to solve is going from every pointer till k items and see whether the elements are alternating or not. In that case, the time complexity will be order of n into k. Or in terms you can say quadratic time, which is not that efficient for great inputs, big inputs like 10⁵. Now what I have to do is, we need to see some kind of way that we can avoid this quadratic time. But let's say when we are starting from index 0, 0, 1, 0, 1, 0. When I'm starting from index 0, this is the group, alternating group. When I'm starting from index 1, this is the alternating group. See, these two items are checked repeatedly. There is a duplication. This is a redundant work that we have to skip. We can only take care of this once and this item once, because these are already taken care. Now this is the idea behind sliding window approach. Sliding window approach means these three is already taken care. Okay. Now if I have to append one more character, I can create a space for that element and then check whether this can be added or not. If this value is not same as the previous one, this can be added and our window will look like this. And if my window is extended, moved further, I'm just going to capture alternating group count ++. Right? So this is the idea behind this approach. We can maintain a sliding window of size k. This is something you can consider as a variation of, so sliding window of size k. But what if the case is something like this: 0, 1, 0, 0, 1, 0, 1, 0. These three are alternating group. Yeah, alternating group is 1 in number. This is not an alternating group. I added one character, one element, or one element from here I removed. So when I am coming to this alternating group, this is not alternating. So what should I do in this case? Should I start from this character? No. Still we are going to not get the answer. If at the end there are two similar elements, there is no sense. We might have to discard every window elements. Now we are going to start from this element, because these two are going to put trouble in every window from the left side. So we have to start from here and check here. If it is alternating, expand the window and keep expanding the window, right? So this is just an idea I wanted to give. Now let's say if I just have a look on the approach, this is the sliding window approach, which we can do using one pointer, or let's say to keep it simple, take two pointer left and right, or you can say I and j. I is pointing to this, j is pointing to this. Now my window is of size 1. One size is not required. I will try to see if I can expand the window or not. Whether the j plus 1 is not equal to j. In that case, I can increment my j. If j plus 1 is not equal to j, in this case I can increment j. And now at this moment, from I to j, my window is of size 3. I can capture this count. Alternating colors count, alternating groups count, ++. Okay, but if the above case is coming here, let's say there is one more 0 and this j cannot be expanded. In this case, we have to reset our window and come I and j to this place, starting a new fresh window from this element. So this is something we have to consider, that when we have to discard the whole window if the current element, let's say j is equal to j plus 1, discard the whole window. One thing you have to keep in mind. Another one is, see, they are saying that this is a circular array. Circular array means when we are coming to 4, we can start our window from 4. If we are starting our window from 4, we can take one element from this and k minus 1 element from the starting. Okay. And what is the next window? Starting from 0. Let me clear you again. 0, 1, 0, 1, 0. This is the array given to us. This is the first window starting from this element. Second window starting from this element. Third window starting from this, starting from this, starting from this. In this case, when I'm starting a window from this will be compared to these two elements if value of k is equal to 3. Correct? And what is the next window after this? Next window after this, starting from this, which we have already covered. Now, it means that last window. At max, we require k minus 1 elements from the starting. If I just do some kind of processing, pre-processing, that 0, 1, 0, 1, 0 is already our array, and I take k minus 1 element from the starting and put in the end 0, 1. Now in this case, do I really need to take care of that circular stuff? No, because this is going to be my last window. Right? So I have reduced this problem from circular to a linear array. Now you don't need to take care of the circular stuff. Linear array, in this linear array, window size is k, and window size we can take a pointer of I and j. Ij pointer of fixed size window on this linear array. This we have practiced in our previous problem yesterday. Okay, now how do we do it? Just apply our basic approach, sliding window style. We have two pointers, I and j. In this case, I am going to compare j with the previous next element. If j is going to be compared with the next element, so j will go till this item, and this is n minus 1, and n is the length of this new array, or you can say, let's say this is the extended one. So while j is less than n minus 1, last index is n minus 1 and j is less than n minus 1. While j is less than n minus 1, we can check our window. See, there is one terminating case. One special case is when j value is equal to the next element. If the j value is equal to the next element, j value equal to the next element, j will always be less than n minus 1, so we can directly compare with n minus j plus 1. If this is the case, so we can reset our pointers to j plus 1. So j is j plus 1 and I is j. Correct? So we are resetting our pointers. And the other case is if they are not same. If jth item and the next item is not same, in that case just increment your window, means incrementing j, incrementing my window. And when I have to capture the count, I am going to capture the count of the window size starting from index I to j, 0, 1, 2, j minus I plus 1, which is 3. These are 3 in number, correct? So if j minus I plus 1 less than k, if it is less than k, we don't need to capture it. It means our window is not of sufficient size. Continue from it. Otherwise, just capture the answer plus plus, and create a space for the next element. See, this much we have to do. And this is the style for sliding window of fixed length. In this case, I just have put one condition. Here we are resetting our sliding window. Now in this approach, we are going to every color integer once. So the time complexity here will be linear 1. Time complexity is order of n and space complexity is order of 1. Now let's code this approach. Here I am taking an extended array. This array is going to be the colors.length plus k minus 1, because in the worst case at max we are going to use k minus 1 element from the starting and 1 element from the ending. So put all the elements in this extended array and k minus element from the starting. Now this is my new array that I need to take care of. Here the n value is extended. We are going to use two pointers. I is initialized with 0, j is also initialized with 0, and we are going to run a loop where ij is less than n minus 1, because I will be comparing extended j with extended j plus 1. extended j plus 1. If the current element is equal to the next element, it means this is a disturbed window and we have to discard the whole window. Now j is going to be reset to j plus 1 and I is also at that position, and we can continue from here. Otherwise, if we are coming to line number 19, we have a valid window and we are ready to extend the size. Now do we have to capture j minus I plus 1 is less than k? If this is the case, we can't capture. Otherwise, capture it. Capture it means answer plus plus. Also create a space for next element in the next iteration, because the window size is of size k. And here I need to take a variable which is my answer variable, and in the end return answer. Let's see if it is working fine or not. No, it is not working fine. Extending the input, n is this, j is equal to 0, int answer equal to, if both are same, just increment the values, continue j plus plus. If j minus I plus 1, why I have put k, j minus I plus 1 is less than k, we just have to ignore this window, otherwise increment it. Now let's test over sample test cases. Sample test cases are fine. Submitting the problem. It got submitted successfully. I hope you understood the approach. It's a standard sliding window, fixed size, but yes, with some modification. Thank you guys. Bye bye.